Welcome to Summarize Science. Have you ever wondered how to build the perfect team of robots for a job like searching a forest or managing a warehouse? Usually, people pick the robots first and the software later, but that is not always the best way to get the job done. Researchers have developed a new framework called task-driven co-design to solve this very problem. These choices are tightly linked, much like how a car's engine size determines what kind of transmission it needs to run efficiently. To address this, the researchers advocate for a phase diagram perspective on multi-agent system design. In physics, phase diagrams show how matter changes from ice to water, but here, they show when a robot fleet should change its structure. The framework uses monotone co-design theory to break down complex systems into smaller, manageable blocks with clear interfaces. Each block represents a part of the system, like the robot's physical components, the planning software, or the specific task goals. These blocks are connected by what they provide, known as functionalities, and what they require, known as resources. For example, a specific drone might provide speed and sensing range, but it requires a certain amount of battery energy and a financial budget. By connecting these pieces, the math can find Pareto-optimal designs, which are the specific combinations that offer the best possible trade-offs. This approach is incredibly efficient compared to the old brute force method of checking every single possible combination. If an engineer tried to test every combination manually, they could easily end up with over 2 trillion different possibilities to evaluate. The co-design system is smart enough to prune away bad or dominated designs early on, so the computer only focuses on the potential winners. To prove the framework works, it was tested on realistic search and coverage missions. The researchers looked at metrics like how much area a fleet could cover and how many hidden targets they could find with high confidence. They even compared different types of planning algorithms to see which one performed best with specific mixes of aerial and ground robots. One case study highlighted how a heterogeneous fleet, mixing different types of robots, can be both faster and cheaper than using just one type. Another test looked at how the system handles uncertainty, such as when the exact mission requirements are not known in advance. They found that a design that is good enough for multiple tasks is often better than one that is perfect for only a single scenario. Let's recap the big ideas from this study on Summarize Science. Designing robot hardware and their software at the same time leads to much better results than doing them separately. This new method uses logic and math to skip trillions of inefficient designs and jump straight to the best options. It can save significant amounts of money and time while making robots much more effective at their jobs. In the future, this could lead to universal robotics phase diagrams that tell engineers exactly what tools they need for any situation. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.